At Flatford Mill, us students have been working around the clock to unearth animal behaviour's greatest mysteries. Questions have been asked such as, why do ducks always misbehave? Why has my water flea disappeared? And where are all the dung flies? But the question on everyone's lips today is, what is optimal foraging? The optimal foraging theory is an idea that an animal will forage in such a way to optimise their net energy intake and minimise their predation risk, whilst still considering the energy cost used. So basically, it's a trade-off between the metabolic expense and the predation risk. A giving up density is the amount of food an animal would be willing to leave behind at a foraging site. The rate of return may also decrease, as the risk of a predator eyeing up the foraging site would increase. In theory, the most favourable foraging site for any small mammal would be somewhere with dense cover where predators cannot see them. So, the question is, will small mammals have a greater giving up density in open areas than in areas of more cover?
To explore this, we'll be setting up 4 different trays in each location, consisting of 100 grams of peanuts and 360 grams of sand.
This is our first location. It's a path leading up to the riverbank, and it's a fairly open grassland area. Here we've set up a 40-metre transect, and along each 10-metre marker we've laid an aluminium tray with 100 grams of peanuts and 360 grams of sand in it. We're also going to lay out 2 porcelain tiles to see if we can find any urine marks on them, and 2 bits of tubing with sellotape inside to maybe catch some hairs if we have any visitors passing through them. So this is our second site. It's an area of woodland next to the riverbank, and it's a lot more, as you can see, undercover than site 1. This is our third site at Valley Farm. It's a slightly more humanised area, but still with quite a high density of woodland. We've collected all of our equipment from the 3 sites, and I'm just going to sieve the sand out of our aluminium trays so we can record the weight of the peanuts that are left.
Now that we've filtered the peanuts from the sand, we need to re-weigh them to calculate how many have been eaten by the mammals.
A one-way between subjects and over was conducted to compare the amount of the foraging of the mammals in the Valley Farm, grass path and river.
As you saw earlier, open areas result in a greater giving up density in small mammals. The area at Valley Farm was foraged the least out of each site. This may be due to increased human activity being a perceived predatory risk. In the daytime, we found not much weight was lost from our feeding trays. This was interesting as the weather today was very wet, and some small mammals actually forage more in the wet weather. However, the peanuts themselves may have taken up some of the rainwater via osmosis, leading to an increase in weight, which may have masked any foraging activity. So, today's mystery solved? If the risk is high and you might die, do not stay, run away.